Row 1. Text, Notepad window, text editor, editing. Blank. Remember, this is not teaching man teacher. It is useful for recalling, when exam coming man student. Just close eyes eye and listen. Based on G scheme for electronics engineering group. Subject, microcontroller, 17534. These are mostly important questions which is always repeat. Form top to end it reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Microcontroller Chapter 3. 1. 4. With the help of ADD instruction explain A. Direct addressing mode B, indirect addressing mode C, register addressing mode D, immediate addressing mode. ANS1 mark for each addressing mode. 1. Direct addressing mode add A plus, add A, 12H. The contents of memory locations specified by 8-bit direct address will be logically added bit by bit with the contents of accumulator. Result is stored in accumulator. 2. Indirect addressing mode add A, at re plus, add A, at R0. The content of memory location, whose address is specified by R0/R1, will be logically added bit by bit with contents of accumulator. Result is stored in accumulator. 3. Register addressing mode add A, RNA plus RN add A, R2. The contents of specified register RN, R0, R7, will be logically added bit by bit with the contents of accumulator. Result stored in accumulator. 4. Immediate addressing mode add A, hashtag data, AA plus hashtag data add A, hashtag 23H. Immediate data is logically added bit by bit with contents of accumulator and result is stored in accumulator. I write an assembly language program for 8051 microcontroller to add 5 8-bit NOS stored in internal RAM from 20H onwards. Store the result at 30H ANS6 marks any correct program with comments. Program for addition of 5 8-bit NOS. CLR PSW.3, select register bank 0 CLR PSW.4, MOV row, hashtag 05H, initialize byte counter move R1, hashtag 20H, initialize memory pointer. Microcontroller Chapter 3. 2. A hashtag 0 microcontroller language program to transfer program to transfer 5 bytes from source block to destination block. Assume source block address is 10H and destination block address is 20H. ANS for MKS proper program ORG0000H, program from 0000H move R3, hashtag 05H, initialize byte counter move R0, hashtag 10H, initialize memory pointer for source array move R1, hashtag 20H. Initialize memory pointer for destination array, therefore R0 source pointer, R1 destination pointer up. Move A at R0, read number from source array MOV at R1, write number to destination array inc R0, increment source memory pointer by 1 inc R1, increment destination memory pointer by 1 DJNZ R3, up. Decrement byte counter by 1, is it 0? No, jump to up here. SJMP here END, stop. 3. Write an assembly language program to send message welcome serially at 9600 baud rate continuously. ANS for MKS for proper program move TMOD, hashtag 20H, timer 1, mode 2 move TH1, hashtag -3, 9600 baud rate move SCON, hashtag 50H, 8-bit data, 1 stop bit, REN enabled set TR1, start timer 1 again, move A, hashtag W, transfer W a call message, some delay move A, hashtag E, transfer E a call message move A, hashtag L, transfer L a call message move A, hashtag C, transfer C a call message move A, hashtag O, transfer O a call message move A, hashtag M, transfer M a call message move A, hashtag E, transfer E a call message SJMP again. Message, MOV SBUF, a. Microcontroller Chapter 3. 4. JNBT1, here, CLRT1, RET. 2. Write an assembly language program to find largest number out of 10 numbers stored in internal RAM location S40H onwards, store the result at 50H. ANS move R1, 0AH, initialize the counter move R0, hashtag 40H, initialize the memory pointer DEC R1, decrement counter by 1 move A, at R0, load number in accumulator move B, move that number to register B up, inc R0, increment the memory pointer move A, at R0, read the next number in A. CJNEA-B down. Compare the first two numbers. If not equal, go to down AJMP next. Else go to next down, JC next. If number in A is greater than go to next move B, else move the number in register B next. DJNZ R1, up, decrement the counter by 1. If count is not equal to 0, then go to up inc R0, increment the memory pointer move A, B MOV 50H. Store result at memory location 50H here, SJMP here. D. Write an assembly language program for 8051 microcontroller to receive 10 bytes of data serially and save them in Accumulator. Assume baud rate is 4800. ANS, proper program for MKS. Move R2, hashtag 0AH, initialize the counter for 10 bytes move TMOD, hashtag 20H, timer 1. Mode 2 move TH1, hashtag -6, 4800 baud move SCON, hashtag 50H, 8-bit data, I stop bit, REN enabled set TR1, start timer 1 here, JNBRI here, wait for the character to come in move A, SBUF, save incoming byte in a move P1, send to port 1 this. Microcontroller Chapter 3. 5. Instruction is optional, CLRRI, get ready to receive next byte DJNZ R2, here, check if all 10 bytes received, if not then wait else stop. END. C. State necessity of assembler directives. List any 4 assembler directives and describe with example. IORG 2, DB 3, EQU 4, ENDANS, IORG. ORG stands for origin. Syntax. The ORG directive is used to indicate the beginning of the address S. The number that comes after ORG can be either in hex or in decimal. If the number is not followed by H, it is decimal, and the assembler will convert it to hex. Some assemblers use .org, notice the dot, instead of ORG for the origin directive. 2. DB, data byte, syntax. Where byte is an 8-bit number represented in either binary, hex, decimal, or ASCII form. There should be at least one space between label and DB. The colon, smiley face, must present after label. This directive can be used at the beginning of program. The label will be used in program instead of actual byte. There should be at least one space between DB and a byte. Following are some DB examples. 3. EQU, equated is used to define constant without occupying a memory location. Syntax. By means of this directive, a numeric value is replaced by a symbol. For e.g. maximum EQU99, after this directive every appearance of the label. Label. Org address. db byte. Name EQU constant. Microcontroller Chapter 3. 6. Maximum in the program, the assembler will interpret as number 99, maximum equals 99. 4. END. This directive must be at the end of every program, meaning that in the source code anything after the END directive is ignored by the assembler. This indicates to the assembler the end of the source file, ASM. Once it encounters this directive, the assembler will stop interpreting program into machine code. E.g. END, end of the program. A. Describe following microcontroller instructions: LJMP address 2, SJMP address 3, RLA 4, RRAANS, 1M each. LJMP address. Long address. The program counter is loaded with the 16-bit long address given in 2 ND and 3 RD byte of the instruction. Jump can take place anywhere in the 64 KB memory space. PC address example, LJMP 3245 HPC 3245. The next instruction executes from the memory location 3245H. 2. SJSJMP address, short address PC new peak-old plus address. The program control jumps max 128 bytes backwards, or max 127 bytes forward with respect to the current PC. Next instruction is executed from new PC. 3. RLA, rotate accumulator left. It stands for rotate accumulator left. The contents of the accumulator are rotated left bitwise. Example, before execution. Microcontroller Chapter 3. 7. 4. RRA, rotate accumulator right. It stands for rotate accumulator right. The contents of the accumulator are rotated right bitwise. Example, before execution. Xchda, at re-exchange the contents of the accumulator with the contents of the memory location pointed by the 8-bit register in the instruction. Example, Xchda, at R1 exchange the contents of the accumulator with the contents of the memory location pointed by the R1 register. 2. CJNEA, direct, rel compare the contents of the accumulator with the 8-bit data directly mentioned in the instruction, and if they are not equal then jump to the relative address mentioned in the instruction. Example, CJNEA, 04H, up compare the contents of the accumulator with the 04H mentioned in the instruction, and if they are not equal then jump to the line of instruction where up label is mentioned. 2. Mul AB multiplies the unsigned value of the accumulator by the unsigned value of the B register. The least significant byte, LSB, of the result is placed in the accumulator, and the most significant byte is placed in the B register. The carry flag, C, is always cleared. The overflow flag, OV, is set if the result is greater than 255, if the most significant byte is not 0, otherwise it is cleared. Example, move A, number 5 move B, number 7. Mul AB, A equals 35, decimal, equals 23H, B equals 00. Microcontroller Chapter 3. 8. 3. Xchda at RI. Exchange digits. The Xchda instructions exchanges only the lower nibble of A with the lower nibble of the RAM location pointed to by RE while leaving the upper nibbles in both places intact. Example, assuming RAM location 40H has the value 97H, find its content after the following instructions: 40H equals 97H, move A, hashtag 12H, A equals 12H. 000100010 binary, move R1, number 40, R1 equals 40H, load pointer Xchda, at R1, exchange the lower nibble of A and RAM location 40H after execution of the Xchda instruction. We have A equals 17H, and RAM location 40H has 92H. For MOVX A, at DPTR this instruction moves the contents of the external RAM memory pointed by, or stored in, DPTR to accumulator. Example, move DPTR, hashtag 2000H, DPTR equals 2000H, external RAM address. MOV A, at DPTR, 2000H equals 0BH, A equals 0BH. 1. Move A, hashtag 40H. This instruction moves, or stores the data 40H in the accumulator. The hashtag symbols tells that 40 is data not address. Example, move A, hashtag 50H, A equals 50H. 4. Swap A description. This instruction exchanges the nibbles, bits 0 to 3 with bits 4 to 7, of the accumulator. This instruction is identical to executing RR or RL 4 times. Example, move A, hashtag 59H, A equals 59H. Swap A equals 95H1. MOVX A, at DPTR description. This instruction moves the contents of the external RAM memory pointed by, or stored in, DPTR to accumulator. Example, move DPTR, hashtag 2000H, DPTR equals 2000H, external RAM address. Assume 2000, 0BH, MOVX A, at DPTR, 2000H, 0BH. Microcontroller Chapter 3. 9. A equals 0BH. 2. Div AB description divides the unsigned value of the accumulator by the unsigned value of the B register. The quotient is placed in the accumulator, and the remainder is placed in the B register. Example, move A, hashtag 0AH. Move B, hashtag 05H. Div AB, A equals 02, decimal, equals 02H, B equals 003. Set C function. This sets high the carry bit. Flags. Carry flag is affected. E.g. set C after execution. Set carry flag CY equals 1. 4. SJMP address. SJMP address. Short address. PC new PC old plus address. The program control jumps max 128 bytes backwards, or max 127 bytes forward with respect to the current PC. Next instruction is executed from new PC. SJMP next. Next, move A, hashtag 30H. Label should be within the range of plus 127 to minus 128. 1. RLCA description. Rotate a byte and carry bit to the left. The carry becomes the LSB, and the MSB becomes the carry 2. XRLA, 15H description. XOR each bit of A with the sum bit of memory location 15H. Put the result in a 3. Div AB description. Divide A and B. Put the integer part of quotient in A and the integer part of remainder in B4. MOVX at DPTR, A. Microcontroller Chapter 3. 10. Description. Copy the data from A to the external address given by DPTR. 1. Xchda, at RI description. The Xchda instructions exchanges only the lower nibble of A with the lower nibble of the RAM location pointed to by RE while leaving the upper nibbles in both places intact. 2. ORLA, R0 description, or each bit of A with the same bit of register R0, and result is stored in A. 3. SETB00H description. Set the bit addressable bit I.E00H to 1. 4. INC DPTR description. Add a 1 to the 16-bit DPTR register.